Hello everyone, I am Abhijit and I am here with another analysis. Here we analyze a dataset which contain different parameters like energy uses, the global horizontal irradiation and other factor. We'll see the dataset and uh, so we'll before going to the dataset, this is some information I would like to we would like to discuss this. This data set contains information about the energy uses and potential difference, energy uses and the potential of different renewable sources in that geographical area. And we will consider that this geographical area as a country, so it will be more easier for us to analyze it. It should be clear that so there is the column where which contains the energy uses. Actually, this column doesn't contain the energy uses, and we will discuss this about when the when we load the data set. So here with one term we have to be familiar, that is GHI. This is global horizontal illustration. So actually this is the uh, uh, this factor will signify the amount of solar energy uh, there in that the amount of solar energy you can say the fall in that geographical area or something. So before going to the analysis, so what is your aim? So okay, before discuss about the aim, so we'll see about see the data set. So before so that we import some of the libraries like NumPy, Pandas, Matplotlib, Seaborn, and when and load that library. Okay. Actually, my computer is some bit slow nowadays, so please pardon me for that. Here we load the data set, and the data set looks like that. Okay. This is the column which I want to talk about. Like it's a energy delta. In engineering term, delta means refers to the difference between two things. So the energy delta here signify that the energy of means if when you see that zero here means it is the difference between this cell means the 27 1 January 27 in this time to this time, the difference of the energy will store here. So I think this is clear for you. GHI, as we already discussed, this is the global horizontal irradiation. Temperature is the temperature of that environment or the temperature of that country in this time period. And pressure, humidity, wind speed, rainfall in millimeter, in snow, cloud coverage. These are all the columns here. So we'll move forward, and before move forward, we'll discuss the aims. So these are the aim for now. If when we will add or some, if we'll found something new, then we'll analyze it further. So these are the basic aims. So here we'll analyze the relation between the energy uses. Like here is the term here is the, you can see the column here, the energy delta. Energy delta means the difference between the energy uses. So basically this is also energy, and this is also signify the energy uses. So we analyze the which factor affect that affected energy delta means when the energy consumption is more, or for which factor the energy increases the energy consumption or something like that. So the second thing, we will find the peak hour for the energy uses. So we know that in the summer time the peak hour is like in the afternoon time or something where we used or the night where we use AC, air conditioner, fans, light, something like everything. So this kind of stuff. So when we use that this kind of stuff, so the energy uses for that time period is peak. Although for a day its average energy usage will be same for most of the time, but during some of the time there is just surge in the energy uses or the energy demand. So we'll find out that time in our data set. So second thing is we will analyze the effect of different parameters as we already discussed. Finally, we'll try to find the reliable energy source. Like if we just there is a thing called, if we just point out the problem, then there is no use. So we have to show a solution here. So actually we'll do this in the two part. Actually the first my first analysis, the first video of my analysis, the first analysis is very long, quite long, and I have found some feedback. So I will make it two parts and as short as possible so that you can understand. And I just only don't makes you understand the analysis, but also I understand how I use the codes, means the logic behind the codes. So here there is here we show the head of the data set. Now we'll go for that. Let's see some information about the data set. Here we can see the number of rows in the every columns and the data type. Here the time is object, energy distribution as usual, 0 0 means it's integer, and gh is a float because you can see 1.6 or something like that, and blah blah everything here. So we'll move towards next point, which is description. Here is statistical description of our data set. Here you can see, and we will find some more interesting information here also. So the counts, when you see that the counts are almost same, there is no null values are here. And for the energy users, you can see the maximum is 5020 and minimum is here 0. 0. Actually, this is different. You should understand. You should always remember this is the difference. So means you should not be confused that when with the energy user is 0 means this is difference between the fast reading and the conjugative reading. Means when I read in the means if you say like I read at 10 a.m. then I read at 11 a.m. If there is no difference between the 10 a.m. reading 11 reading, then it will 0. So this is the delta. It is not about how much reading is there in the 10 a.m. So actually, so I think you will understand that. So there is a difference between like the average delta is 520, it is the maximum, and minimum is 0. So actually, okay, the minimum should be 0, like the difference between the two either is equals to or there is a value there. So there is a the mean is 573. You can see the GHI, the global horizontal irradiation. Actually, we would use this factor for our solar energy. Actually, this factor is used for the solar energy production. Like we'll see that it will affect the solar energy production. We'll discuss in the further part of the video. So you can see that the minimum is 0, means that in the night time, there is no solar energy, so it must be 0, and maximum is 229, and I think it is the watt per meter square. This value is in the watt per meter square. Okay, then the temperature, the minimum temperature is minus 16 and maximum is 35 degrees Celsius. And pressure, you can see here, wind speed, and every single factor is defined. Actually, which is in the numeric form, will define. Okay, now we'll go for the null variable. Actually, we can see that it's no null. So for our confirmation, we will give this, and we can find there is no null. I'm sorry. Okay, yeah, there's no null variable. Okay, let's find out the data set here, and here we go. Till now, there is no codes, like no hard codes. These are the basic codes, so I don't think I should. There is any problem in that code to understand. Okay, so these are the code. Here we have 17 columns, and this number amount. This is the amount of the rows here. It's quite a long data set, quite a heavy data set. Okay, so here you can see that this timestamp or this column contains the year, month, date, and the hour. And because we already have here the we can see the month column, so we don't need another generative month column, but we need to generate year column. So for my easy or for easy of the analysis, I use that method. If you want to do this, then it's up to you, or if you want to do another way, you are always welcome. Okay, so the first step I uses here to convert it into a list. So I use it two list function. This is the data, this is the digit column, and this is the function where I convert this column to a list function. So here, if you want to see how this list look like, you can see here. This is long data set. So everything is here. Then I just create two columns, like I want a year column as I already discussed, and I want a time column. Time column means it will contain 0. You can see here, it will contain that region here. Time column will contain this time. Okay, actually this time I use it this time because I will have a already here we will have a our column here, but I use this because it will generate more information. Like I have to prove by according to that. This is the, we can do that, but here I use because I have the data, so I should not use it, right? So so here I create a blank list, like there is no values there. Then I run a for loop. How many number of time? The number of time will define at the length of the or the like length of the list. So I use the range function. Inside the range function, I use the length of the time. And if you ask why, there is there is multiple way, but this way is like I use this way because it is easy to use. So here we'll give you a numeric value and which will the value for the range, and then this many time the range will the power flow will be iterate. So here I append the year column, which is a blank column. Here you will say the time with just the string operation is here, like time of 5 and it will be 0. So time of 5 is it will take this value, then it will take this value, and after taking this value it will just slash this amount of the this many part of the row, which will be, you can see that 0 1 2 3. You know that it will count the first element also, element, but excluding the last. So 0 1 2 and 3, and this is our year. Okay, now for the time, we will do the same thing for the year. We'll append that blank list for I means 0. We'll first it will take this much amount, this much, then it will start the slicing from the 11th position. So you can see it is the 0 1 2 3 4 5 6 7 8 9 10, and this is 11 to rest. So we'll have our this much of time, which will be our time. Here we'll run that, then we already have our so we have our year end time list. So now we'll get it here. Now we'll take it to the and we'll introduce to our data set. So this is the easiest way to introduce. Like we'll just create a year column here, and now we'll put the value here. This is the data, this is the location, this is the data, this is the location, and we'll and what is about this? Actually, sometime when you put this put the year or you put any value this way, this will store as an object in the data type will be object. I just want to be I want to be a numeric value. If you want to do it, or else you can leave. So this is the way you will change your data type to integer. Because this code is repeated, so just forget it. So now we have our data set on our desired form. We can, if you want to remove the columns, like these columns are not necessary in that, like sunlight time, day length, sunlight time divided by day length. Uh, these are not necessary for us because all the things are can be derived from the GHI. So if you want to remove, then you can remove. I don't remove it because actually because I don't need it, and again most if you want to remove, then remove. But here I don't remove it. Okay. Then go to now we can go to our analysis. Before, if you want to see the data set how it looks like, then here is our data set after adding columns, you can rearrange the columns using like uh, in between you can rearrange the columns here the year. Okay, we already have here. Still, let's just tell it. Okay, so this is the problem, right? Here is the capital Y and here the small y. If we force the capital Y, then it will do our thing. Now, if you see, then we have only 1 year column. So, because by the way, it's case sensitive. Okay, here is already there, right? Okay, just going to then okay. You want just drop the column or it's up to you. Don't worry, it will not do no harm to your analysis. So if you want to drop this to your column, you can drop it or just leave it. Okay, okay, we'll go to our next like the analysis. So before that, we want to see how our data looks like because this is in 1 lakh or something more than 1 lakh column, so we cannot see manually. So let's see, we can see the distribution of the different parameters like energy and different in the histograms. So here our histogram. Okay, you can see the most of the time the energy need is same, but like we already discussed, the most of the time of a day or most of the time of the energy, the requirement of the energy is stagnant or the same. But sometime or the some in the some time of a day or some in the some hour, there is a need for the energy. There is a positive. There is a want for the more energy. So here there is a difference. Like you can see 100 to like 5,000. These are the sometime more energy required. You can like and for that we will do. We will find out in which time this happen or what is the cause of this in the we'll discuss in this analysis. So here we'll go for the this is the PF, this is the histogram from the matplotlib, and you can see this is the same. This will save those show the same, just the visualization difference. The most part of the zero means there is low. There is most of the time there is the energy need is same. Okay, or the energy consumption is same. So now the we'll see the THI in the global horizontal radiation, like how much it is in the distribution type. Yeah, 0. Uh, from that all the data set, I just assume that this quantity, this geographical location is present somewhat in the pole, either in the pole side, like north or south pole, in that area. So most of the time, like you can see, global origin radiation is 0 because these are the data sets. I don't actually uh, what you call. I don't. I was confident about the authenticity or about the data set because this is the data set we use and from what is the analysis we do here. So this is what it show like. Then okay, now we'll show the wind speed here. So on the average, the wind speed is the 2 meter per second to like 6 meter per second. You can say it is slow. The now less time it have the 8 meter per second and more in the 2 to 4 meter per second. The wind speed lie between 2 and 4. So now we have the sunlight for daytime. If you want to do this, because as you said, there is no huge because you can although if you want to use it like you can correlate between this graph and then this graph, you can see that the GHI distribution is more towards the zero type, and here also the zero type. So sunlight or daytime, like as usual, the GHI will be there, the global horizontal irradiation will be there when the sun is in the sky. Okay, and the horizontal, like as per the definition. Now we can see the temperature. Yeah, the temperature mostly lies from the 0 to 20, and minus 10 is the harsh condition, like the negative here. Most of the time it will lie from the 0 degree. You can see that this is the concentration here, 0 degree to 20 degree. Okay, now we'll go for the, okay, here. In this plot, we'll see the change in the energy need with respect to the time. Okay, y axis in time and y is the energy delta here. And there is no much information you can find here. Like this is mostly cluttered, so we found some other way to find it. Okay, here. Okay, in this plot, we have a subplots. So in the first plot, and like we'll see what is like this. What is this? So here we'll see the temperature. How in the basic, in the common sense, we know that the most of the time we use the energy either when we feel very, the temperature is more or the temperature is very low. For the more temperature, we use air conditioner, fan, fridge, other type of thing. And for the, if the temperature is very low, then now we will use the room heaters, boilers or something like that. So temperature is the primary factor, for the, it should be the, should be a primary factor for the energy consumption. So I take it first to see whether I find any relation between the temperature and the energy consumption. So what will be our result? Here this is the subplot. We can generate two plot at a time, two or multiple plots at a time. We just need to define the axis. That's all. Okay, you can see here the temperature and the time, here the energy delta and the time. You can clearly see. You can actually this is, there is no confusion. You can clearly see every peak in the temperature is having every the same peak in the energy delta. Energy delta, I repeatedly say, this is not the energy used. Energy delta is the difference between the energy used between two consecutive steps. So there is, when the temperature increases, then the energy used from the previous is more. Then the temperature decreases simultaneously. This is also decreases. You can see this is for the all year, not for the 1 year. You can here say 2017, here is 2022. So energy uses and the temperature of the environment is directly related. When the temperature is increases, the energy usage increases. When the temperature decreases, the energy usage decreases. So here we will find the most important, you can say most important correlation between our environmental condition to the energy usage. Okay, now we'll dig more. So here we clearly show like that, as we already discussed. Now, okay, in this figure we don't have much more answer about our like the time to the energy delta. So we will use, and as I told, I will use a different method. So this is the different method. Now we'll see here the mean energy conversion with consumption. Here this is the energy consumption. This is not a production, sorry, this is a consumption. Mean energy consumption to the time. You can see this is like a Gaussian system, means a Gaussian plot something. Here is the peak, like like it's a regular peak and cross line. So you can see this is the 2017, 2018. If you say that this is January, then this is the January 2018. So we can see here in the middle of the time the energy consumption is more. You can see for every year this is the same. And as we know, if you say if we say this is till this is the time where the summer is exist, or this is the time where the summer is there. So here we will also see that the here the energy consumption is more during this period. So we'll find out more because this graph we actually find more things in that graph, but we'll visualize um, more clearly from the next graphs. Here we'll go for and see the hourly in each hour. We already told that there is a peak hour where the energy is more, the consumption of the energy is more. So we'll find out the peak hour of energy, which is so here the peak hour energy is 5 to 15, like that. So you can see the 5 in the morning, 5:15 in the afternoon, 3 and 5 energy rises is more and then decreases, maybe because of the human activities, the industrial activities, or any other thing in that area or in that geographical location of the country. And you can also call it about the temperature, because this is the daytime. So uh, offices are open, other fields of other government systems, or the residential, we use this air conditioner or other things. So this is, you will see a source of energy. Yeah, a source of energy requirement. Okay, now we'll see the same relation with the month. In which month we have the we require more energy. So here with the requirement of more energy is like 4 to 8. So if you so the fourth month is April, and like it's the 8th. So this is the time, basically this is summer time, like the April end of the April, the summer stuff begins, and it will exist till July or September, like the September October, like September October. So you can see here 8th or 9th month, for the consecutive 4 month, there is a peak of energy. So this all the graphs indicates or signifies or validate our analysis that the temperature rise or the temperature of that environment is directly related to the consumption of the energy, more consumption. Okay, so now we'll see the okay. Okay. Now we'll see the temperature of the average temperature in the each hour. So just before going to that, just I will just recall you that this is the average mean energy requirement, or the mean energy delta. The maximum it is here in the maximum in the 10. You can see the 5 to 15. Can this is the same for the temperature, mean temperature. You can find here. You can see it is the 5 rising 15 and stop. So all the graph signifies that our analysis is in the right way, like the temperature directly proportional to the delta energy delta of get the different the energy source. Okay, now okay from in that in this analysis, we clearly establish our relation between one of the significant variable or the significant environmental factor, which is the temperature. Rain is not, as you know, that rain is not directly related to the energy consumption, because if there is rain, there is no logic that we will use, like the umbrella don't use electricity, right, or anything like that. So temperature is the most factor, the relatable factor for the energy uses. So in the next so this video will be here, and with the next part we will go for our analysis for the to when we find the analysis, when we find the most reliable source of energy, right? Like we in this data set we have three type of energy: in this solar energy, hydro energy, and wind energy. And how I find out there is a type of possible energy in the renewable part, you can see here. GHI already said this is directly related to this solar energy. And here the wind speed, the what is the basis of the wind energy? This is the speed of the wind, or the wind energy. Like the speed more, the speed of the wind will turn the turbine or rotate the turbine, and turbine subsequently provide us the electricity. Although the turbine doesn't provide us the electricity, this is provided by the generator or the alternator. turbine just provide the necessary rotation. Right. Okay. We won't go there in that engineering field. Now you have the rain. Yeah, hydroelectricity works on the river. Most of the river, not when there is no glacier in a country or something like the rivers are depends on the rain. If rain is more, then there is a chance of building a dam on a river if the like that. So you can say, so you have the solar, wind, and hydroelectricity. There is no mention of the nuclear energy, so we'll leave it. So in this video, that's all. Uh, have a good day, good night. Depends when you watch the video. Please watch my videos and give me comments if you like that analysis. And please subscribe to my channel, and please watch the second part where we actually analyze the factor or the energy, the source of the energy, and there we use the and there I will describe all the logic behind my course. In this video, I can't do that. There is a time constraint. So in the next video, I will definitely understand you the logic behind the course, and it's very easy. So good night, sweet dreams.